So now we want to look at rational inequalities. Okay, so we looked at rational equations. So now what happens if we're looking at inequality instead? And this will have similar rules as when we looked at polynomial inequalities. Kind of the same idea where we're going to want to use a sign chart. So let's look at 3x plus 5 plus 1 over 2x plus 1 is greater than 1. Okay. So a few things going on here. And there's a few different ways we could approach this. I think the best way to approach these is to get everything on one side. Okay, so we just want to look at, is it positive or is it negative, essentially. So in other words, we're going to bring the 1 over. We're going to subtract 1 from both sides. And we're going to have 3x plus 5 plus 1 over 2x plus 1 minus 1 is greater than 0. So this is just like in the polynomial case where we kind of want to get everything to one side first. Same idea here. And now, because these are rational expressions, we do need to go ahead and find a common denominator. Okay. You might be tempted to just multiply both sides by 2x plus 1. It's not really a good idea here because we don't know if that 2x plus 1 is positive or negative, right? Since it has that x in it. So we would really need to, we'd have to break it up into cases when it's positive and when it's negative, split it into two different problems. It would be a little bit messier. So it's better to just combine it all into one fraction instead. So here the only denominator is 2x plus 1. So we'll go ahead and multiply everything by 2x plus 1 over 2x plus 1. Or at least the terms that aren't already over 2x plus 1. Okay, so we get 2x plus 1 times 3x plus 5. And this is all going to be over 2x plus 1. So that's from the first term. Plus 1, that's from the second term. And here minus 1 times 2x plus 1. Okay, and that's greater than 0. Now, we'll go ahead and do the multiplication and combine everything here. So we'll have 6x squared plus 3x plus 10x plus 5 plus 1 minus 2x minus 1. All over 2x plus 1 is greater than 0. And then finally we should combine like terms on the top. So we have 6x squared. Here we have 13x minus 2x is 11x. And then we have 5 plus 1 minus 1, so 5. And now once everything's combined, we do want to try to factor it because we do need, if we're going to go to the sign chart, we're going to need our zeros. So this whole thing is 0 when the numerator is 0. Okay, so we're essentially just working with a quadratic here. We need to know, where is this quadratic equal to 0? And maybe you want to do this as a separate problem on the side. It might be easier. So 6x squared plus 11x plus 5 equals 0. Okay, so let's think about it. Can we factor this? Looks like this should be 6x plus 5 plus 1, right? So this will be 6x plus 5x is 11x. So that should be good. So we have x equals negative 5/6 or x equals negative 1. So if you recall for the sign chart, what we need is the zeros, which we have here. So this is kind of like a number line, so kind of line them up. Negative 5/6 is larger than negative 1. Now in this case, we also need the problematic numbers. Sometimes maybe we call them the bad numbers. the numbers that will make the denominator 0 in this case. In other words, the numbers that are outside the domain. And the reason for that is that weird things can happen at that point. And in fact, let's go ahead and look at that. Okay, if we were just to graph this function, just so we can see what it looks like, because we haven't looked at any graphs of rational functions yet. Okay. So we want this. Maybe it'd be better to put this in parentheses so that it will know that we divide the whole thing. Okay, so it's going to look something like this. So the key point here is the number that's going to make the denominator equal to 0 is -1/2. Okay, because 2x plus 1 equaling 0 would be -1/2. So note what's happening around -1/2. Okay, this is -1. You can see our -5/6 here, our other 0. -1/2 would be around like right here. You can see on the bottom part of this, what it's doing is it's getting closer and closer to -1/2, but it's not touching it. You can see it's getting closer to the -0.5. Actually, it doesn't look like it comes up. Oh, there it is. All right, there we go. So -0.5 is getting closer and closer to that. And then on the top half, it's getting closer and closer to -1/2 from the other side. Okay. So this is called a limit, which we'll talk about, or an asymptote in the context of the graph. But for now, all I just wanted to show was that this needs to be considered on the sign chart, because this is a place, at the zeros, we're going from positive to negative. Right here, it goes from negative to positive, so we can already see what's happening on the sign chart, actually. It just has this little dip into the positive here. But also at that number that is outside the domain, the problematic number, it's also switching between negative to positive abruptly. So weird things can happen at those numbers. So it's important to keep both of those on the sign chart. Okay. So let's go ahead and throw that -1/2 on there. Okay. And some people like to label them. So this would be your 0, this would be your 0, this should be your bad number. I like to label them with a frowny face. And this isn't really like important for this context, but later when we're like making graphs out of these sign charts, it becomes more useful. So now we need some test numbers. So we'll do f of 0. Actually, we didn't even call this a function, right? So f doesn't really make sense. But anyway, if we just plug in x equals 0, this is going to be 5/1, which is positive. And remember, we're looking for the part where it's positive, right? Because it's greater than 0. Now it's going to get a little trickier. We're going to have to use some not so nice numbers. Maybe x equals -0.75, -3/4. So that's going to be negative. Okay, I won't actually plug it in because it just could be a tedious calculation, but we can just see from the graph that we looked at that it's going to be negative right there. And this part's going to be positive, and this part's going to be negative. This would be pretty hard to find a number to test in between, right? Maybe you could do like -0.9, plug that in, and you should get a positive number. And then on the other side, you just plug in like -2, and you should get a negative number. Okay. So regardless, our final answer here then would be just the parts where it's positive. So we would have x in -1 to -5/6, neither of which are included because, no, they're not included because it's not greater than or equal to, right? It's just greater than. Union -1/2, the -1/2 can never be included, whether it's greater than or equal to or just greater than, because that's the number that makes the denominator 0 to infinity. Okay, So that would be our final answer.